Good morning. My name is Selvam. As an assistant professor, mechanical engineering in Kogonadu College of Engineering and Technologies. I talk about the subject of dynamics of machines. The unit 2 balancings. Balancing is can be divided into two types of balancing. One is the balancing of rotating mass. Another one is the balancing of reciprocating mass. What is made by balancings? The machine has many moving parts. Some machines have rotating motion and some of them have reciprocating motion. If the moving parts are not in complete balance, inertia force are set up which may causes excessive noise, vibration, wear and tear of the system. Balancing is process of designing or modifying the machinery so that the unbalance is reduced to an acceptable level and if possible is eliminated entirely. Types of balancings. The balancing can be divided into two types. One is the balancing of rotating mass, another one is the balancing of reciprocating mass. First one, balancing of rotating masses. Balancing of a single rotating mass by a single mass rotating in the same plane. The second one, balance of single rotating mass by two masses rotating in the different planes. Third one, balancing of different masses rotating in the same plane. Then fourth one, balancing of different masses rotating in different planes. First one, balancing of a single rotating mass by a single mass rotating in the same planes. This is the diagrams. Is considered the disturbing mass m1 attached to a shaft rotating at omega radians per second. Let r1 be the radius of rotation of the mass m1. Centrifugal force exerted by the mass m1 on the shaft Fc1 is equal to m1 omega squared into r1. Centrifugal force due to mass m2 Fc2 is equal to m2 omega squared into r2. Then second one, balancing of single rotating mass by two masses rotating in different planes. For two balancing masses are placed in two different planes parallel to the plane of rotation of disturbing masses in such a way that they satisfy the following two conditions of equilibrium. One is the net dynamic force acting on the shaft is equal to 0. This requires that the line of the action of three centrifugal forces must be the same. This is the condition for static balancings. Second one, the net couple due to the dynamic forces acting on the shaft is equal to 0. The algebraic sum of the moments about any point in the plane must be 0. The third one, balancing of several masses rotating in the same plane. This is the diagrams. Consider any number of masses, that is the four masses of magnitude m1, m2, m3 and m4 at a distance of r1, r2, r3 and r4 from the axis of the rotating shaft. Let theta 1, theta 2, theta 3 and theta 4 be the angle of these masses which the horizontal line of OX is shown in figures. So the balancing is determined the two types. One is the analytical method, another one is the graphical method. Then analytical method find out the masses. First of all, find out the centrifugal forces each exerted by the each mass on the rotating shaft. The second one, resolve the centrifugal force horizontally and vertically and find their sums, that is the summation of H and summation of V we know that sum of the horizontal components of the centrifugal forces summation of H is equal to m1 r1 cos theta 1 plus m2 r2 cos theta 2 etc. And the sum of vertical components of the centrifugal forces summation of V is equal to m1 r1 sin theta 1 plus m2 r2 sin theta 2 etc. The third step, magnitude of resultant centrifugal forces. F is equal to root of summation of h squared plus summation of v squared. Then fourth step, if the theta is the angle which the resultant force makes with the horizontal, then tan theta is equal to summation of v divided by summation of h. Then fifth step, the balancing force is then equal to the resultant force but in opposite direction. Now find out the magnitude of the balancing mass such that F is equal to m into r. M is the balancing masses and r is the radius of rotations. The next one, balancing of several masses rotating in different planes is shown in figures. When several masses resolve in different planes, they may be transferred to a reference plane, that is the OV. The technique is to transfer the centrifugal force acting in each plane to a single parallel plane, which is usually termed as reference planes. Then the procedure for balancing is almost the same as for different forces acting in the same planes. The next one, complete balance of several revolving masses in different planes. The following two conditions must be satisfied. One is the force in the reference plane must balance, that is the resultant force must be zero. The couples must be reference plane must balance, that is the resultant couple must be zeros. Then take one of the planes, say L, as the reference plane. The distance of all other planes to the left of the reference plane may be regarded as negative and those to the right as positive. The values are plotted in the tables. Then draw the unknown masses, that is the balancing masses. Draw the diagrams, force couple force diagram and couple polygon, force polygon diagram and couple polygon diagrams. For force polygon diagram, the values are taken from the table, that is the centrifugal forces, and couple polygon diagram, the values are taken from the table in the couples. Draw the diagram and find out the unbalancing masses. The next topic, balancing of reciprocating masses. The various in the figure, the various force acting on the reciprocating parts of an engine. The resultant of all the forces acting on the body of the engine due to inertia force only is known as the unbalanced forces or sagging forces. Thus, if the resultant of all the forces due to inertia effect is zero, then there will be no unbalanced force, but even then the unbalanced couple or shaking couple will be present. Let Fr is equal to force required to accelerate the reciprocating parts. Fi is equal to inertia force due to the reciprocating parts. Then Fn is equal to force on the side of the cylinder walls or normal force acting on the gasket guides, and the Fb is equal to force acting on the crankshaft bearing or main bearing. Since Fr and Fi are equal in magnitude but opposite in direction, therefore they balance each other. The horizontal component of Fb acting along the line of reciprocation is also equal and opposite to Fi. This force Fbh is equal to Fu is an unbalanced force or shaking force and required to be properly balanced. Thus, the purpose of balancing the reciprocating mass is to eliminate the shaking force and the shaking couple. In most of the mechanisms, we can reduce the shaking force and a shaking couple by adding appropriate balancing mass, but it is usually not practical to eliminate them completely. In other words, the reciprocating masses are only partially balanced. The partial balance of locomotive engine. Most of the locomotives used in our country are of two cylinders of the same dimensions. The crank of the two cylinders are placed at right angles to each other in order to have uniformity in turning moment diagrams. The next one, type of the locomotives. Type of the locomotives can two-cylinder locomotives. It can be classified into two types. One is the uncoupled locomotives. Another one is the coupled locomotives. Uncoupled locomotives inside a cylinder, then other one outside cylinders. Coupled locomotives inside a cylinder and then other side and the outside cylinders is based on the number of pair of the wheels coupled. Coupled locomotives, if two or more pair of the trailing wheels are coupled to driving wheels in order to increase the adhesive force between the wheels and the track, it is called coupled locomotives. Uncoupled or single locomotive. In uncoupled locomotives, there is only one pair of the driving wheels is used. This type of locomotives have become obsolete nowadays. The second one, based on the arrangement of two cylinders. Inside cylinder locomotives, then another one outside cylinder locomotives. Inside cylinder locomotives, if the two cylinders are placed between the wheels, then it is called inside cylinder locomotives. Outside cylinder locomotives, if the cylinders are placed outside the driving wheels, it is called outside cylinder locomotives. Thank you.